It uses the setInterval function that we've seen in the animation code in previous chapters to update the ball's position at regular intervals. Add this code after the code from the previous section. SetInterval function ctx.clearRect 0, 0, width, height. Ball.draw, ball.move. ctx.strokeRect 0, 0, width, height. 30. We use setInterval to call our animation function every 30 milliseconds. The function first clears the entire canvas with clearRect and then calls the draw and move methods on the ball. As we've seen, the draw method simply draws a circle at the ball's current location, and the move method updates the ball's position based on its x speed and y speed properties. Finally, it draws a border with strokeRect so we can see the edge of the canvas. Now that we've gone through all the code, erase the full listing for your convenience. Var canvas equals document.getElementViewed canvas var ctx equals canvas.getContext 2D var width equals canvas width var height equals canvas height var circle equals function x, y, radius, fill circle ctx.beginPath ctx.arcs, y, radius, 0, math.pi 2, false. If fill circle ctx.fill else ctx.stroke / the ball constructor var ball equals function this x equals width /2 this y equals height /2 this dot x speed equals 5 this dot y speed equals 0 / update the ball's position based on its speed ball.prototype dot move equals function this x equals this dot x speed this y equals this dot y speed. If this x this x equals width else if this x width this x equals 0 else if this y this y equals height else if this dot y height this dot y equals 0 / draw the ball at its current position ball.prototype dot draw equals function circle this x this y 10 true / set the ball's direction based on a string ball.prototype dot set direction equals function direction. If direction equals this dot x speed equals 0 this dot y speed equals -5 else if direction equals down this dot x speed equals 0 this dot y speed equals 5 else if direction equals. Left. This dot x speed equals -5. This dot y speed equals 0. Else if direction equals. Right. This dot x speed equals 5. This dot y speed equals 0. Else if direction equals. Stop. This dot x speed equals 0. This dot y speed equals 0. / the key down handler that will be called for every key press. Body. Dot key down. Function. Event. Var direction. Equals key actions. Event dot key code. Ball dot set direction. / the animation function, called every 30 milliseconds set interval. Function. ctx.clearRect 0, 0, width, height. Ball.draw. Ball.move. ctx.strokeRect 0, 0, width, height. 30. Now our program is complete. When you run the program, you should see a black ball moving across the canvas to the right, as shown in figure 15-3. W. When it reaches the right side of the canvas, it should wrap around to the left side and keep moving to the right. W. When you press the arrow keys, the ball should change direction, and pressing the space bar should make the ball stop. Figure 15-3. A. Screenshot from the moving ball animation. Note if the animation doesn't respond to keys as expected, click the page to make sure the program can access your key presses. In this chapter, you learned how to make programs that react to keyboard events. We used this knowledge to create a moving ball, where the ball's direction is set by the keyboard. Now that we can draw to the canvas, create animations, and update those animations based on user input, we can create a simple canvas-based game. In the next chapter, we'll recreate the classic snake game, combining everything we've learned up until now. Here are a few ways you can build on the final animation to make it more sophisticated. 1. Bouncing off the walls. Modify the code so the ball bounces off the side and top walls instead of wrapping around to the other side. Hint: just reverse the direction when the ball hits the wall. 2. Controlling the speed. The ball currently moves 5 pixels for every step of the animation. This is because set direction always sets x speed or y speed to -5 or 5. Create a new property in the ball constructor called speed and set it to 5. Then use this instead of the number 5 and set direction. Now, change your code so that you can use the number keys to set the speed from 1 to 9. Hint: create an object called speeds, and use it to determine the new speed, if any, based on the key down event. 3. Flexible controls. Modify your code so that when you press the Z key, the ball slows down, and when you press the X key, it speeds up. Once that's working, use C to make the ball smaller and V to make it larger. What happens if the speed goes below 0? What about the size? Add a check in the code to make sure the speed and size never go below 0. In this chapter and the next, we'll build our own version of the classic arcade game Snake. In Snake, the player uses the keyboard to control a snake by directing its movement up, down, left, or right. As the snake moves around the playing area, apples appear. When the snake reaches an apple, it eats the apple and grows longer. But if the snake hits a wall or runs into part of its own body, the game is over. As you create this game, you will combine many of the tools and techniques you've learned so far, including jQuery and the canvas as well as animation and interactivity. In this chapter, we'll look at the general structure of the game and go through the code for drawing the border and the score and ending the game. In Chapter 17, we'll write the code for the snake and the apple and then put everything together to complete the game. Figure 16:1 shows what our finished game will look like. W. I'll need to keep track of and draw 4 items on the screen as the game runs: the border in gray, the score in black, the snake in blue, and the apple in lime green. Figure 16:1. Oh. Your snake game. Before we start writing code, let's take a look at the overall structure of the game. This pseudocode describes what our program needs to do. Set up the canvas, set score to 0, create snake, create apple. Every 100 milliseconds. Clear the canvas, draw current score on the screen, move snake in current direction if snake collides with wall or itself. End the game. Else if snake eats an apple. Add 1 to score, move apple to new location, make snake longer. For each segment of the snake, draw the segment. Draw apple, draw border. When the user presses a key, if the key is an arrow, update the direction of the snake. Over the course of this chapter and the next, we'll write the code to execute each of these steps. But first, let's talk through some of the major parts of this program and plan out some of the JavaScript tools we'll use for them. Methods that update and draw everything to the game board. Just as we've done in Chapter 14 and Chapter 15, we'll use setInterval to animate the game by calling those functions at regular intervals. This is what our call to setInterval will look like in the final program. Var intervalid equals setInterval function ctx.clearRect 0, 0, width, height. Draw score. Snake.move. Snake.draw. Apple.draw. Draw border. 100. In the function that we pass to setInterval, the first line clears the canvas with clearRect so that we can draw the next step in the animation. Next we see several function and method calls. Notice that these all roughly match up with the steps in the pseudocode listing on the previous page. Also notice that we save the interval ID in the variable intervalid. We'll need that interval ID when the game is over and we want to stop the animation. See ending the game. Represent the 2 main objects in the game, the snake and the apple. We'll create a constructor for each of these objects called snake and apple. And we'll add methods like move and draw to the prototypes of these constructors. We'll also divide the game board into a grid and then create a constructor called block, which we'll use to create objects that represent squares in the grid. We'll use these block objects to represent the location of segments of the snake, and we'll use a single block object to store the apple's current location. These blocks will also have methods to let us draw the segments of the snake and the apple. The player to control the snake using the arrow keys on the keyboard, we'll use jQuery to respond to key presses, as we did in Chapter 15. We'll identify the key that was pressed by looking up the key code, and then we'll set the snake's direction accordingly. Now that we've gone through an overview of how the program will work, let's start writing some code. In this chapter, we'll start by setting up the HTML, the canvas, and some variables we'll need throughout the program. Then we'll tackle a few of the more straightforward functions we need for this game: 1 to draw the border around the board, 1 to draw the score on the screen, and 1 to end the game. In the next chapter, we'll create the constructors and methods for the snake and apple, create an event handler for arrow key presses, and put it all together to complete the game. CTX. Width and height. To get the width and height of the canvas element, var canvas equals document dot get element vid canvas var CTX equals canvas dot get context 2D var width equals canvas width var height equals canvas height. The code in the HTML sets the width and height to 400 pixels. If you change those dimensions in the HTML, width and height will match the new dimensions. Shown in figure 16:2. The grid will be invisible, that is, the game won't actually display it. Everything in the game will be drawn to line up with it. Figure 16:2. 10-pixel grid showing the block layout of the game. The snake and apple will both be one block wide so that they fit within this grid. F. Or every step of the width in blocks equal to the width of the canvas divided by the block size, which tells us how many blocks wide the canvas is. Similarly, height in blocks tells us how many blocks tall the canvas is. At the moment the canvas is 400 pixels wide and tall, so width in blocks and height in blocks will both be 40. If you count the number of squares in figure 16:2 including the border, you will see that it's 40 blocks wide and tall. Score. Var score equals 0. Well, use the score variable to keep track of the player's score. Because this is the beginning of the program, we set score equal to 0. Well, increment it by 1 every time the snake eats an apple. Next, well, create a draw border function to draw a border around the canvas. Well, make this border 1 block 10 pixels thick. Our function will draw 4 long, thin rectangles, 1 for each edge of the border. Each rectangle will be block size 10 pixels thick and the full width or height of the canvas. Var draw border equals function ctx.fill style equals gray ctx.fillRect 0, 0, width, block size ctx.fillRect 0, height, block size, width, block size ctx.fillRect 0, 0, block size, height ctx.fillRect width, block size, 0, block size, height. First we set the fill style to gray, because we want the border to be gray. Then, we draw the top edge of the border. Here we're drawing a rectangle starting at 0, 0 the top left corner of the canvas. With a width of 400 pixels and a height of block size 10 pixels. Next, we draw the bottom edge of the border. This will be a rectangle at the coordinates 0, height, block size, or 0, 390. This is 10 pixels up from the bottom of the canvas, on the left. Like the top border, this rectangle has a width and a height of block size. Figure 16:3 shows what the top and bottom borders look like. Figure 16:3. The top and bottom borders. If we draw the left border, and if we draw the right one. Figure 16:4 shows the addition of these two edges. Figure 16:4. The left and right borders with the top and bottom borders shown in a lighter gray. Now let's write a draw score function to display the score at the top left of the canvas, as shown in figure 16:1. This function will use the fill text context method to add text to the canvas. Fill text method takes a text string and the x and y coordinates where you want to display that text. For example, ctx.fillText. Hello world. 50, 50. Would write the string hello world. A. T. The coordinates 50, 50 on your canvas. Figure 16 to 5 shows how that would look. Figure 16 to 5. The string hello world. DRA. WN at the point 50, 50. Hey look, we printed text to the canvas. But what if we want to have more control over how the text looks by tweaking the size and font or changing the alignment? 4. The score in our snake game. We might want to use a different font, make the text bigger, and make sure the text appears precisely in the top left corner, just below the border. So, before we write our drawScore function, let's learn a little more about the fillText method and look at some ways to customize how text appears on the canvas. Bottom left corner of the text is lined up with the baseline point so that the text appears above and to the right of that point. To change where the text appears in relation to the baseline, we can change the text baseline property. The default value for this property is bottom. But you can also set the text baseline property to top or middle. Figure 16 to 6 shows how the text is aligned for each of these options, in relation to the baseline point shown as a red dot that you pass to fill text. Figure 16 to 6. TH. E effect of changing text baseline. For example, to run your text below the baseline, enter ctx.textBaseline equals top ctx.fillText. Hello world. 50, 50. Now, when you call fillText, the text will be below the point 50, 50, as you can see in figure 16 to 7. Figure 16 to 7. A. String hello world. With text baseline set to top. Similarly, to change the horizontal position of the text relative to the baseline point, you can set the text align property to left, center, or right. Fig. Year 16 to 8 shows the results. Font. Context. This listing shows some examples of different fonts we could use. ctx.font equals 20px courier. ctx.fillText courier 50, 50. ctx.font equals 24px Comic Sans ms. ctx.fillText Comic Sans 50, 100. ctx.font equals 18px Arial. ctx.fillText Arial 50, 150. The font property takes a string that includes the size and the name of the font you want to use. For example, and we set the font property to 20px courier, which means the text will be drawn at a size of 20 pixels in the font courier. Figure 16 to 9 shows how these different fonts look when drawn on the canvas. Figure 16 to 9. 20px courier, 24px Comic Sans, and 18px Arial. Draw score. Score on the canvas. Bar draw score equals function ctx.font equals 20px courier ctx.fillStyle equals black ctx.textAlign equals left. ctx.textBaseline equals top. ctx.fillText score. Score, block size, block size. This function sets the font to 20 pixel Courier 20px Courier. Sets its color to black using fill style. Left aligns the text with the text align property, and then sets the text baseline property to top. Next, we call fill text with the string score score. The score variable holds the player's current score as a number. We set the starting score to 0 at the beginning of the game in defining the score variable, so at first this will display score 0. When we call fill text, we set the x and y coordinates to block size. Since we set block size to 10, this sets the score's baseline point to 10, which is just inside the top left corner of the border. And since we set text baseline to top, the text will appear just below that baseline point, as shown in figure 16 to 10. Figure 16 to 10. The position of the score text. Well, call the game over function to end the game when the snake hits the wall or runs into itself. The game over function uses clear interval to stop the game and writes the text game over on the canvas. Here's what the game over function looks like. Bar game over equals function clear interval intervalid ctx.font equals 60px Courier ctx.fillStyle equals black ctx.textAlign equals center ctx.textBaseline equals middle ctx.fillText game over width /2 height /2. First we stop the game by calling clear interval and passing in the variable intervalid. This cancels the set interval animation function that we created in using set interval to animate the game. Next, we set our font to 60 pixel Courier in black, center the text, and set the text baseline property to middle. We then call fill text and tell it to draw the string game over, with width /2 for this position and height /2 for the y position. The resulting game over text will be centered in the canvas, as shown in figure 16 to 11. Figure 16 to 11. The game over screen, after the snake has hit the left wall. In this chapter, we looked at the general outline of our snake game and some of the functions we'll need to make the game. You learned how to draw text onto a canvas and how to customize its size, font, and position. In the next chapter, we'll finish off our game by writing the code for the snake and the apple and to handle keyboard events. Here are a few exercises you can try before you go on to finish programming the game. 1. Putting it together. Although I haven't shown all the code for the game yet, you can run the code for drawing the border and the score. Take your HTML file from creating the HTML and add the code for setting up the canvas, creating the score, drawing the border, and drawing the score. Now you just need to call draw border and draw score to see the border and score. It should look just like figure 16 to 10. Why? Oh, you can try out the game over function, too, but before you call that function, you will need to delete the clear intervalid line. Why? Oh, you haven't created the intervalid variable yet, so for now, if you call the function without removing that line, it will produce an error. 2. Animating the score. Write your own call to set interval with a function that increases the score by 1 and then draws the updated score using the drawScore function every 100 milliseconds. R. Remember that you will need to clear the canvas each time, using the clearRect method on the canvas context. 3. Adding text to Hangman. Programming Challenge 4 in Chapter 13 was to draw the man in our Hangman game using canvas. T. Re-extending your Hangman game by using the fill text method to draw the current word underneath the Hangman, as shown. Hint: to underline each letter, I've used 30 pixel long stroked lines, with 10 pixels between each one. For even more of a challenge, draw the incorrect guesses crossed out, as shown to the right. In this chapter, we'll finish building our snake game. In Chapter 16, we set up the playing area and covered how the game would work in general. Now we'll create the objects that represent